In the final module of week 3, we complete our survey of climate-neutral electricity options by looking at a range of technologies we ignored so far. Ocean energy, nuclear fusion, nuclear fission, bioenergy, and the use of carbon capture and storage, CCS, to capture emissions from power plants are on the menu. Some of these technologies are interesting in principle, but not yet commercially available. Because the energy transition needs to happen as soon as possible, these technologies are therefore unlikely to play a major role in it. Ocean energy is a good example of such a technology. There are many different ways to exploit the motion of the ocean, or to exploit thermal or osmotic gradients, that is, differences in salt concentration, to generate electricity. In some parts of the world, this could be an interesting option. However, no technologies are commercially available at the moment. Nuclear fusion is an even more extreme example. If it were widely available and cost competitive, our energy problems would be more or less solved. But it is very difficult to achieve since it is trying to do something very hard: reproduce the conditions inside the sun. There's no telling when it might be commercially available, but it will not be in time for the emission reductions we need now. Nuclear fission, on the other hand, is very attractive in principle because it is essentially emissions-free and it is available now. Globally, about 10% of total electricity demand at the moment comes from nuclear. It makes sense to keep operating existing reactors for as long as they are safe, although the definition of safe is debated. Debates go on about this plant, for example, the oldest still operating nuclear power plant in the world, in Switzerland. The current generation of nuclear fission technology comes with many issues. It creates long-lived radioactive waste, material for nuclear weapons, can result in catastrophes if something goes wrong. It is also expensive and cannot by itself compete on the market. For the reason of economic competitiveness alone, it makes little sense to build more nuclear reactors with the current generation of technology. But what about new kinds of nuclear reactors? Small modular reactors, molten salt reactors, and various other technologies at different stages of development or commercialization. These next-generation technologies solve most issues that plague the current generation of nuclear power plants. But again, none of them are commercially available right now, and there is no telling when they will be, if at all. So this is something to keep an eye on and to invest further research and development efforts, but not something that we will be spending more time on in this course. Finally, bioenergy and carbon capture and storage, CCS. Both of them are controversial. For example, land use competition with food production or ecosystem protection for bioenergy, and with CCS, the implied continued reliance on fossil fuels, which is problematic for many reasons. We do not have the time to delve into these in any detail. I just want to say that they're attractive because they work the way that power plants traditionally worked. Burn stuff, drive a turbine, to turn a generator. So none of the variability problems of renewables. And if you burn plants that absorb CO2 from the atmosphere when growing, then capture that CO2 with CCS, you can actually pull emissions out of the atmosphere, which will probably be needed to avoid catastrophic climate change. But both bioenergy and CCS might be more urgently needed outside of the electricity sector, for example in industrial processes, which you talked about in weeks 1 and 2. So again, something to keep an eye on, but we will leave these aside for now. Ultimately, from all the technologies we looked at, the ones that tick most boxes to rapidly deliver very large amounts of climate-neutral electricity over the next decade or so are PV and wind. These two alone will not solve the problem. We have lots of other options floating around here on the side, many of which are playing a role and will play a role. But it is difficult to see how the challenge will be met without PV and wind. The only problem is that they have such high variability. And that is a very considerable problem. So, next week, we will explore the different solutions to deal with this variability. See you then.